Hello guys, this is Langzel's here, and today we'll continue fluorine. Now with that out of the way, let's get into it. Chapter 4. Fluorine compounds. There are millions of different compounds all around you. A compound is formed when two or more elements are bonded together. Fluorine is so reactive that it bonds with virtually every element. For this reason, fluorine is never found by itself in nature. It is always found in compounds. During a reaction, fluorine steals electrons from other elements to fill its outer electron shell. All the halogens had a tendency to gain one electron, bringing the number of electrons in the atom shells to 8. Atoms are usually electrically neutral, which means they carry no charge. They carry no charge because they have an equal number of positively charged protons and negatively charged electrons. However, if an atom picks up an extra negatively charged electron, it becomes a negatively charged ion. In the same manner, if an atom loses the electrons, it becomes a positively charged ion. When the fluorine atom gains an electron, it becomes a fluoride ion. Fluorine ions have one charge, negative one part charge, because they have one extra electron in their outer shell. Once fluorine has filled its outer electron shell, it will not give up the electron easily. For this reason, the compounds that fluorine forms are very stable. Fluorine bonds with other elements to form many different interesting and useful compounds. Hydrofluoric acid. Hydrogen fluoride HF gas dissolved in water to form hydrofluoric acid. Hydrofluoric acid is extremely corrosive because it's so destructive. It must be stored in lead, PB, steel, or plastic containers that themselves are made with fluorine. Hydrofluoric acid even dissolves glass. Around 1670, the use of hydrofluoric acid for etching glass was first described by Heron Swarnhard. Today, this fluorine compound is still used to etch glass. During etching, glass is first discovered by an acid-resistant substance, such as wax, to protect the parts of the glass outside the pattern. The acid then eats away the uncovered surface of the glass. The etched glass surface may take on a rough, frosted appearance or have a soft, stained tea appearance. Etching is used to create designs in glassware or ceramics. It is also used to mark the division on photometer tubes and to create the frosty, stainty finish on the inside of electric light bulbs. There are 2 electrons in the electron shells and 7 electrons in the outer shell of a neutral fluorine atom. Left. However, a fluorine atom is stable and only has 8 electrons in its outer shell. Fluorine seeks to complete its outer shell by gaining an extra electron, which creates a negatively charged fluoride ion. Right. 1, 2, 3, 4, 5, 6, 7, 8. This one. 1, 2, 3, 4, 5, 6, 7, 8. What? 1, 2. They both have 8. Glass etching uses acid to create patterns on the surface of the glass. The graduated markings and labels of this laboratory glassware were created using hydrofluoric acid. Sodium aluminum fluoride. Let me say it again. Sodium aluminum fluoride. For thousands of years, people have been using minerals containing fluorine to purify metal. Today, they use these minerals without even knowing that fluorine existed. We still use fluorine compounds to purify metals. In fact, the largest use of fluorine compounds today is for refining the aluminum, Al, metal. Like fluorine, aluminum is always found in combination with other elements in nature. To obtain the pure aluminum that we use to make soda cans, foil, cars, airplanes, and aluminum must be first separated from the other elements to which it is bonded. To separate aluminum from other elements, a fluorine compound called cryolite is needed. Cryolite, or sodium aluminum fluoride, Na3AlF6, is a mineral found in the uranium hexafluoride in the Earth's crust. It is composed of the elements sodium, Na, aluminum, and fluoride. Impure aluminum bound to other elements, it's dissolved in a bath of hot, molten cryolite. When electricity is passed through the bath, pure aluminum is formed. This process is called electrolysis. What? Uranium hexafluoride. Uranium hexafluoride (UF6) is a fluorine-containing compound that is produced from fluorine gas. This gaseous compound is used to refine the uranium fuel that is used in nuclear power plants. The nuclear power plants make electricity using the energy produced by the fission of uranium fuel. During fission, uranium splits the two lighter elements. This process gives off an extreme amount of energy in the form of heat and radiation. Uranium exists in many different isotopes. The isotopes of uranium have different masses. The sum of the protons and neutrons in the nucleus. Pure uranium consists of mostly U-238. Uranium with a mass of 238, however, only the U-235 uranium with a mass of 235 isotope can be used as a nuclear fuel. Fluorine helps to separate these two isotopes so that the U-235 isotope can be used. Pure uranium is combined with fluorine to form uranium hexafluoride, UF6, rather toxic and remarkable gas. Its molecules are extremely heavy for a gas. Most gases have much lighter molecules. This gas is spun at high speeds and filtered through a thin membrane to attain the useful U-235. The Montreal Protocol. The Montreal Protocol is an international treaty that was designed to protect the ozone layer. It phased out the production of the substances believed to be responsible for the depletion of the ozone layer. The treaty called for the eventual end of the manufacture of CFCs. The Montreal Protocol took effect on January 1st, 1989. Because of its acceptance by so many nations, as of 2006, 189 nations had referred to the protocol. The Montreal Protocol has been hailed as an example of international cooperation. Fluorocarbons. The CFC or CFCs are a group of compounds that contain the elements fluorine, chlorine, and carbon. The CFCs are odorless, non-flammable, non-corrosive, non-toxic chemicals. CFCs were developed in the late 1920s. They soon became widely used as refrigerants in refrigerators, freezers, air conditioners, and heat pumps. They're also used as propellants and aerosol dispensers. They also it's also served as insulating, used in propellants, foam and packaging materials, car seats, and beddings. By 1970s, however, scientists were concerned that CFCs escaping into the atmosphere were damaging the ozone layer. In the upper atmosphere, ozone is formed in the stratosphere, the layer above the air we breathe. By action of ultraviolet light on oxygen, ozone gas is a special oxygen molecule that is made up of free oxygen atoms. Freed ozone layer helps us by blocking out the rays that the sun that can harm our skin and the tissues of plants. Humans couldn't last long without plants. If the protective ozone layer were to disappear, we'd be exposed to dangerous levels of ultraviolet radiation. This could weaken our immune systems or cause contracts or cancer. Because of their effects on the ozone layer, the United States banned the use of CFCs in aerosol dispensers in 1978. Chapter 5. Fluorine and you. When elements join together to form compounds, they lose their visual traits. When fluorine forms compounds of other elements, it undergoes interesting and often dramatic changes to its properties. Fluorine can be a very dangerous element. Its compounds can be very helpless to us. Fluorine and your teeth. Tooth decay from even too much sugar has become a real problem for people in many countries. One of the most remarkable uses of fluorine is to keep teeth from developing cavities. Teeth are protected by a hard enamel made of mineral called let's call it HS. HX. In the presence of sugar, bacteria in the mouth forms acids that break down the HX. This loss of tooth enamel causes teeth to decay. Toothpastes which contain fluorine in the form of a sodium fluorine or sodium fluorophosphates can help prevent cavities. In humans, fluoride mutates in bones and teeth. When sodium fluoride is present in the body and makes a modified form of tooth enamel, instead of HX, it forms fluorapactate. Okay, I just call it FP. FP is more resistant to attack from acids in the mouth. Because of this, many communities in the United States now add fluoride to public drinking water. The amount of sugar in the food we eat is a major factor in the development of tooth decay. A pretzel, honey nut Cheerios, and a Mars cracker were crushed and tested with betterment solution, blue liquid to determine sugar content. In presence of some sugar, a green or brown or red color precipitate will form. All free food contain sugar. Fluorine in food. And food, not in. The average person consumes about 0.0000011 and 0.00011 ounces, 0.3 or 3 milligrams of fluorine every day. Most of this fluoride is produced by the fluoridated water supply, but fluoride is found in other foods as well. Foods such as pork, eggs, chicken, potatoes, cheese, and butter all contain traces of fluoride. Even a cup of tea can provide you with much as 0.00014 ounces, 0.4 milligrams of fluoride. Seawater contains a good amount of fluoride too, but we don't drink seawater. We eat foods that come from the sea because of the environment from which they come. Things like cod, salmon, and mackerel Oh, God, salmon and mackerel. What's mackerel? Fluorosis. Fluorosis is caused by the consumption of too much fluoride. Fluoride can enter the body through toothpaste, drinking water, drugs, and fluoride dust, and fumes from industries using fluoride containing salt or hydrofluoric acid. Fluoride that has been consumed and then applicates in the bones and teeth. There are two types of fluorosis: skeletal and dental fluorosis. Skeletal fluorosis and crippling bone disease that mostly affects other people in India and China. In India, the most common cause of fluorosis is naturally fluoridated water found in wells dug deep into the earth. In China, most people become sick by burning fluoride-enriched coal in their homes or field. The early symptoms of skeletal fluorosis are similar to those of arthritis, causing painful stiff joints and sensation of burning or tingling in the limbs. Not literal burning, the sensation, right? The muscle weakness, however, the end result can be quite disfiguring. Arms and legs become weak, it becomes difficult to move joints, and vertebrae typically fuse together, crippling the patient. Dental fluorosis is characterized by white specks or brown markings on the teeth. It's been found to affect from 30% to 50% of children in areas where fluoride has been added to drinking water. And sardines are particularly rich in fluoride. Even vegetables contain a little bit of fluoride. Cookware, raincoats, and hearts. One of the fluoride compounds, CF, has proven to be very useful to us. It's made from extract of crude oil, ethanol, ethylene, and fluoride. When C2F4 molecules are linked together to form a chain, they're known as Teflon, which is a soft white plastic that virtually nothing sticks to. Teflon is a non-stick surface used on many household cooking utensils and cookware. It helps to make metals healthier because it reduces the need for fat in cooking. Teflon also makes cleaning up after dinner a lot easier because food does not burn and stick to the bottom of the Teflon-coated pots and pans. This experiment shows how fluoride rinse can protect teeth. Eggshells, like teeth, can be weakened by acid. Photo 1 shows an egg being placed in the fluoride rinse solution. Where was I? Photo 1 shows an egg being placed in the fluoride rinse solution. Photo 2 shows the fluoride treated egg being placed in a cup of white vinegar, which is a weak acid similar to those found in the person's mouth. An untreated egg is also placed in vinegar. In photo 3, the untreated egg, right, and bubbles and the acid attacks the shell, but the treated egg, left, is protected from an attack. Oh, whoa. Wow. Because Teflon has such amazing properties, it has many other uses as well. In 1969, Bob Gore, chemical engineer and co-founder of DuPont, discovered a way to expand the compound so that it formed invisible pores. He called the material Gore-Tex. Gore-Tex is considered waterproof because the pores are small enough to keep liquid water droplets out, but large enough to allow the gaseous water molecules from sweat to escape. Because of this property, it is used to make rain gear. Gore-Tex is not only good for a rainy day, but is also used to create artificial veins and arteries for people with cardiovascular disorders. Considering the extreme activity of fluorine gas, it might not seem surprising that fluorine compounds are stable enough for one to be used as a part of someone's heart. However, fluorine compounds are perfectly safe.